To find the equation of the circle in standard form, I'm going to first get all the variables on one side and the constants on the other. So I'll add x squared to both sides and add 20 to both sides. So over here we have x squared plus 4x plus y squared minus 2y equals 20. Okay, so my goal, my standard form for a circle always looks like this. So now I need to figure out what I need to complete the squares. So over here, half of 4x is, half of 4, the coefficient of x is positive 2. And then when I do 2 squared, I need to create an extra 4. Then over here, half of negative 2 is negative 1. So when I do negative 1 squared, negative 1 times negative 1 is positive 1. And then since I add 1 out of nowhere on the left side, I also need to add 1 on the right side. So the right side, 20 plus 4 plus 1 is 25. And here is the standard form of the circle. Write the equation of a circle with center 4, 6. Well, so first of all, standard form for a circle looks like this. So we're given h and k, so we can plug those in. And all we need to do is to figure out the radius squared. Okay, so center's at 4, 6, and there's another point on the circle at 5, 9. So the radius is the distance between those 2 points. So I'll use the distance formula. So distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then the square root of all that. So I'll call this point x2 and y2, and this point x1 and y1. So substituting that in, 5 minus 4 squared plus 9 minus 6 squared. Okay, so the radius is radical 10, but remember, I don't care about the radius, I need the radius squared. So if I square both sides, r squared is 10. Okay, question 3, find equation of the circle with diameter endpoints 18, negative 13, and 4, negative 3. 18, negative 13, and 4, negative 3. So first I'm going to need the center, so I'm going to use the midpoint formula for that. So first you combine the x coordinates, 18 plus 4, and then you find halfway between them, and you repeat for the y coordinates. So 22 over 2 and negative 16 over 2. Okay, so the center of our circle is 11, negative 8, but we also need the radius. Okay, so the radius, this is 11, 8, negative 8. So the radius is not from the starting 2 points, that's the diameter. It's from one of the endpoints to the center. So we need to use the distance formula to find the radius. I'll call this x2, y2, and this x1, y1. And then I use the distance formula. So subtract the x coordinates, 18 minus 11 squared, plus the difference of the y coordinates, negative 13 minus negative 8 squared. Okay, over here we have 7 squared plus negative 13 minus negative 8 is like negative 13 plus 8, which is negative 5. So then 49 plus 25 equals radical 74, and this is the radius. Well, if r equals radical 74, I know that I really need r squared. R squared equals regular 74. So now I have all the information I need to write the equation of the circle. I have the center, which tells me h and k, and I just calculated r squared. So the general formula for the circle is x minus h squared plus y minus k squared equals r squared. So x minus 11 squared plus y minus k. Well, y minus -8 turns into y plus 8. Don't forget the squared, and equals r squared, which is 74. Find the equation of the parabola in vertex form. So first, I'll get the y by itself. So I want to keep y positive, so I'm going to move everything to the other side. So I need to subtract the x squared over, subtract the 4x over, and add the 28 over. Okay, so y equals negative x squared minus 4x plus 28. So this is standard form, but they ask for vertex form. So to find the vertex, I start by getting the x-coordinate using the axis of symmetry formula, negative b over 2a. So b is the coefficient of the x term, and a is the coefficient of the x squared term. So b is -4, so I have negative 4. And then over 2 times a the coefficient of x squared, it's -1. So simplifying, I get 4 over -2 equals -2. So the x-coordinate of the vertex is -2, but now I need the y-coordinate. So the equation tells me how to calculate the y-coordinate. I just plug in -2 for all the x's. Okay, so order of operations, we do exponent first. -2 squared, -2 times itself is +4. Then you stick on the negative sign, so -4. -4 times -2 is +8, and then we keep the plus 28. So -4 plus 8 is 4, plus 28 is 32. So the vertex is -2, 32. Okay, so vertex form of a parabola looks like this. So h is the x-coordinate of the vertex, k is the y-coordinate of the vertex, and a, we already said, is the coefficient of the x squared. So in this case, a is -1. Then we have x minus -2, which is really +2. Keep the squared, and then plus k is 32. Find the equation of a parabola with vertex 3, 4 and directrix y equals 13/4. So first I'm going to sketch a picture so I know which direction the parabola opens. So we got 3, 4 is the vertex, and the directrix at 13/4, which is 3 1/4. So in this case, the directrix is below, meaning the parabola opens upward. Okay, so we're going to use vertex form for the parabola because we already know the vertex. So here's what vertex form of a parabola looks like. So we already know h is the x-coordinate of the vertex. We already know k is the y-coordinate of the vertex. So the only thing left to figure out is what is a. So the equation we need to use is that the distance from vertex to the directrix equals 1 over 4a. So we don't know a, that's what we're trying to figure out, but we do know the distance between the vertex and the directrix. The vertex has a y-coordinate of 4, and the directrix has y-coordinates of 3 1/4. So the distance between them is 3/4 of a unit. Okay, so now we just need to solve for a. So I'll start by multiplying both sides by a. Multiply both sides by 4. So these cancel out, these cancel out. I get 3a equals 1. And then divide both sides by 3. Okay, a is 1/3, so now I just plug that in for a. Here's the final equation. For 6, measure of DE is 84. So arc DE, well, arc DE gets intercepted by angle DGE. This is an inscribed angle. So inscribed angles are half of their intercepted arc. So measure of DE is 84, so half of that is 42 degrees. Okay, and then measure of EFD. Well, that inscribed angle also intercepts the same arc. So it is also half of 84, meaning 42 degrees. Okay, so 7, I see a circumscribed angle, an angle with its vertex outside the circle. And the property I know is that circumscribed angle plus central angle is 180 because they're supplementary. So combine like terms, x plus 2x is 3x, 1 minus 7 is negative 6. Add 6 to both sides. And divide both sides by 3 to get x equals 61. Okay, measure of angle NQM. Well, NQM is x plus 1. So if x is 61, 61 plus 1 is 62. Oh, sorry, I made a calculation mistake. 186 divided by 3 is actually 62. So that means that measure of NQM is 62 plus 1, which is 63. Okay, PNQ. Well, this is formed by a tangent and its radius, so I know that's 90 degrees. And then finally, NPM, I plug in 62 for x. Here we have two chords intersecting, so that means the product of their pieces is equal. So x times 5 equals 2 times 10. So 5x equals 20. Divide both sides by 5, x equals 4. Here we see an inscribed quadrilateral in a circle. So the property we know is that opposite angles are supplementary, meaning they add to 180. So angle B and angle D are supplementary, meaning they add to 180. So that means that both of them must be 90. Hold on, which angle is? Angle ABC is 90 degrees. Okay, but then they also ask about angle DAB. So for that one, we need the x's. And again, opposite angles add up to 180. So 16x plus 8 plus 8x plus 4 equals 180. 24x plus 12 equals 180. Subtract 12 from both sides. 24x equals 168. And that means x is 7. Okay, but they didn't ask for x, they asked for angle DAB, so I need to plug in 7 for x. So 16 times 7 plus 8, that's 112 plus 8, that's 120. Central angle with O, length of the radius and measure of POQ are shown. What is the length of arc PQ? Okay, so first I find what would be the full circumference. So that'd be 2 pi r, in this case 2 pi times 10, which is 20 pi. And then now I need to multiply by what fraction of the circle do I actually have. I have 80 out of the full 360 degrees. Okay, so if you multiply this together, you will see that it is closest to 14. Okay, and then which one is the closest to the area of POQ? So this time, since I'm dealing with area, I need to find what is the full area first of the whole circle. So area of a circle is pi r squared. In this case, radius is 10. So the full circle is 100 pi. And then again, I don't have the full circle. I have 80 out of 360 degrees. So when you multiply 100 pi times 80 over 360, this is closest to 70. Length of arc TS is 12. What is the length of RS? Okay, well, RS is related to this angle. So I know the full circle is 360. So far, we've used up 260 degrees. So that means there's 100 degrees left over for this central angle. And I want to know the length of RS. Okay, so an 80-degree angle led to a 12-degree arc. So then I want to know 100-degree angle leads to what arc? Okay, so I cross multiply. 80x equals 12 times 100, and then divide both sides by 80. So x would equal 15. Okay, these are both diameters, and wy is equal to xz, which is 6. So diameters get cut into half. So if the whole thing is 6, that means that each piece is a radius of 3. The measure of arc xy is 140 degrees. What is the length of yz? Okay, so I can tell that xy and yz combine to half the circle. Half the circle is 180. So if 140 of it's over here, that means that there's 40 degrees left over for arc YZ. So we're asked for the length though. So this is the measure. We want the length. So the full circle is the circumference, 2 pi r. In this case, 2 times pi times 3. The full circle has circumference 6 pi. But we only have 40 out of the full 360 degrees. Okay, so multiplying this, we get 6 pi times, we can reduce this to 1/9. So that equals 6 pi over 9, which reduces to 2/3 pi. Convert to degree measure. So if I have 5 pi out of 8 radians, the full circle is 2 pi radians. So first I want to figure out what fraction of the circle do I actually have. So fraction division, 5 pi over 8 divided by 2 pi. To divide fractions, we multiply by the reciprocal of the second number. The pi's cancel out, so that gives us 5/16. Okay, so we have 5/16 of the full circle, and because we want degrees, the full circle is 360 degrees. Okay, so we just need to multiply these together to get our answer of 112.5 degrees. Okay, repeat the process for 8 pi over 9. I got to figure out what fraction of the full circle is 8 pi over 9 radians. So 8 pi over 9 divided by 2 pi leads to 8 pi over 9 times 1 over 2 pi, which is 4/9. So I have 4/9 of the full circle. The full circle is 360 degrees. So this means it's equivalent to 160 degrees. Okay, so 1 radian, there's no pi, but it's still radians. Okay, so I have 1 radian out of the 2 pi full circle, and I want to, so this is already a fraction, and then a full circle would have been 360 degrees. Okay, so we just need to simplify this. Okay, so this is approximately 57.3 degrees. Convert degrees to radians. So I want to figure out what fraction of the full circle is represented. So I have 70 out of 360 degrees. And then, well, let me simplify first. So I can divide by 10, 7 out of 36. So this angle is 7/36 of the full circle. And then I multiply by the full circle, which is 2 pi radians. Okay, so 320, what fraction of the full circle is that? So this reduces to 8/9. I have 8/9 of the full circle. So if I call the full circle 2 pi, what is 8/9 of that? That's 16/9 pi. Central angle is pi over 6. Radius is 4. What is the length of the arc? Okay, so we're talking about lengths. So the full length is the circumference, 2 pi r. In this case, 8 pi is the circumference. But what fraction of the full circle do we have? We have pi over 6 out of 2 pi. So let's reduce this fraction off to the side. So to divide, we multiply by the reciprocal. And we see that this angle, represents 6 times 2. We have 1/12 of the full circle. Okay, so the full circumference is 8 pi, but I've only got 1/12 of it. So that would be 8/12 pi, which reduces to 2/3 pi. Okay, circle with radius 4 inches. What is the area of a sector intercepted by an inscribed angle of 2 pi over 3? So first, let's focus on the inscribed angle part of it. So if the inscribed angle is 2 pi over 3, the relationship between the arc and the inscribed angle is that the arc is double the angle. So if the inscribed angle is 2 pi over 3, the arc is 4 pi over 3. Okay, so the full area of the circle would be pi r squared. In this case, r is 4. So the full circle is 16 pi, but what fraction of it do we have? So the part we have is 4 pi over 3 out of a total of 2 pi. So I'm going to simplify this fraction first. 4 pi over 3 divided by 2 pi. Multiply by the reciprocal of the second number. Cancel out the pi's. Reduce. Okay, so it looks like we have 2/3 of the full circle. So the full circle is 16 pi, and then we have 2/3 of it. So we have 32 thirds pi inches squared.